Hi there. This lesson is about proving that two triangles are similar. If you remember, similar triangles have the same shape, but they're not necessarily the same size. So have a look at these two triangles. Are those two triangles the same shape? Well, if you're thinking ahead, you're going to be thinking, you can tell an angle, a shape's shape by looking at its angles. So if we've got 105 and 45, we must be able to figure out this missing triangle, or the missing angle there. So that angle is going to be 180 minus 150, so we're going to end up with 30 there. Why is my pen not working? So we're going to end up with 30 in here. And similarly up in this one, we're going to end up with 30 degrees in the corner there, because 105 plus 45 plus 30 is 180. So just knowing two angles is enough to be able to say that a triangle is the same shape. So yes, we can say these two triangles are the same. Let's label the angles. We need to be able to write down a proof. A, B and C. We call this one D, E and F. And we can say definitively that A and angle A and angle D are the same. How do we know they're the same? Because they're both equal to 45 degrees. It's given. And we can say that angle B is equal to angle E, both 105 degrees. That was given. And that's enough. That is enough to say that, therefore, triangle ABC is similar to, and here's a new symbol. I'm going to write congruent, but I actually want to use the symbol for similar to. It's three lines, one all up and down. So it's similar to DEF because they have equal angles. Now, you'll notice that we haven't mentioned the 30-degree angles. We don't have to. Okay, any fool can do that maths. It's not a big deal. So we don't bother about it. We just give two angles the same, and then we say they've got equal angles. Now, in some textbooks, you will see they don't use the word equal angles. They have the word equiangular. You need to be able to use that word as well. Okay, so either equal angles or equiangular will do. What about another example where you don't know the angles? Okay, so this is a question. Is triangle ABC similar to triangle DEF? Are these two triangles similar? Well, we need to look at the sides for this one. Remember that if a triangle has sides, if two triangles have sides in the same ratio, then they are similar. So we need to look at the ratio between AB and the similar side, or the corresponding side, DE. Okay, so AB to D, hang on, upside down. It's image over original. So I better turn that up, put that up the right way around. DE over AB is equal to 15 over 10, which is equal to 3 over 2. You could use 1.5 there. I'm not fussy, but I'm a mathematician, so I'm going to stick with the fractions. Now, what about, let's say, B, or EF and BC? Does that give us the same scale factor? EF is 9 and BC is 6, and that simplifies to 3 over 2. You could write 1.5, I don't mind. So it looks good, we're in the right way, but let's check one more. FD over CA. FD is 12, CA is 9. Divide top and bottom by 3, and you get 4 over 3. Hang on, they're different. These are not similar triangles. This side looks like it's not quite long enough. Not quite long enough. This one was multiplied by 1.5. This pair was multiplied by 1.5. But this one was only multiplied by 1 1/3. Okay, so they're not the same. So I write the conclusion, therefore, triangle ABC is not similar to triangle DEF, and the reason is sides are not in the same ratio. Now, of course, if in some parallel universe this had been changed so that it was 1.5 times as big as that, so if it was 13.5, because if you multiply 9 by 1.5, you get 13.5. So if it had been there, you would have got 3/2 when you simplify the fraction, and it would have worked out. And we would have had to say that they are similar. But I just thought I'd give you an example where they don't.